Welcome back. Another fun day of math. We're going to do 4.4 today, which is looking at trig functions for any angle, not just angles on the unit circle. Just going to be a lot of SOHCAHTOA, some right triangle trig stuff, some working in quadrants stuff. So nothing super crazy today, hopefully. And we will get started. Okay, we have 3 objectives today. The first objective, oh, I guess I could turn my pen on, huh? There we go. The first objective is we are going to evaluate trig functions of any angle. So we're going to figure out what's the sine of this or the tangent or whatever. Okay, then we're going to use reference angles, and we talked about reference angles back in 4.1, I believe. And so I'll talk about what they are again, but we're going to use reference angles to evaluate trig functions. And then we're going to use trig functions of real numbers, or evaluate trig functions of real numbers. So just by definition here, I don't really want to scroll down yet, but definitions of trig functions of any angle, just as a reminder, SOHCAHTOA again, okay? So if I have a quadrant 1, let's just say, I'm just going to draw a random angle, and we will call this theta. Okay, so if I have theta, and I don't know what theta is, it doesn't matter, it's a real number, okay? I can create this right triangle with the x-axis. This point right here, as we talked about last time, this is point P, so that's my xy. So really, right, this value right here is y, this value right here is x, and then this value, they're calling it r because that's the radius, okay? And then we're just using SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the cosecant, secant, and cotangents are just the reciprocals of those. So nothing really that new there, just as another reminder of where we're getting the sine, cosines, tangents. So let's look at an example of when we use that, okay? Again, I'm a visual person, so I like to be visual here, but if that's something that you're not interested in, then that's fine. Okay, so this is let -3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So since I'm at the point -3, 4, I know that that's in quadrant 2 somewhere. Okay, so this is the point -3, 4, somewhere in quadrant 2. And I can make that triangle. This is theta, because I don't know what theta is. And there's my right triangle. Well, that tells me that my x value is -3 and my y value is 4. So if I want sine, let's do sine of theta first. I need opposite, which is 4, over hypotenuse. Well, I don't know what my hypotenuse is. But I do have this right triangle that I can use Pythagorean's theorem on, right? So a squared plus b squared equals c squared. So I can use Pythagorean's theorem on this. I have -3 squared plus 4 squared equals c squared. So that gives me +9 plus 16 equals c squared. 25 equals c squared, so 5 equals c. So my hypotenuse is 5. So sine then is opposite over hypotenuse. So my hypotenuse is 5. Then if I want to find cosine of theta is adjacent over hypotenuse, so my cosine is -3 over 5. And then tangent of theta is opposite over adjacent. So you can write this as as 4 over -3, or you can just do -4 over 3, or you can do -4 over 3. Okay, so 3 different ways to write it, doesn't matter, whatever you feel comfortable with. So just kind of using that visual of drawing that triangle, that means, you know, we can find sine, cosine, tangent from any point, which is kind of nice. The next thing that we're going to look at here is when are our trig functions positive? So I'm curious is when are they positive? So again, remember our trig functions are sine, cosine, tangent, and then cosecant, secant, and cotangent. Okay, so in quadrant 1, I'm just going to draw a random line that I'm going to erase this later, so you don't have to keep if you don't want. So here's this. Sine is the y value. Well, that's positive, right? Cosine's the x value, so that's positive. Tangent is the y over the x, so that's positive. Cosecant is the reciprocal of sine, so positive. The reciprocal of cosine is going to be positive, and then the reciprocal of tangent is going to be positive. So in quadrant 1, all of them, all 6 of them are positive in quadrant 1. In quadrant 2, if I draw my triangle, my x coordinate here is negative. My y coordinate, is positive. So sine is my y. So sine here is positive, which means also right away cosecant is also positive. Okay. Cosine is negative, which means secant is negative. Tangent would be y over x, so positive over negative, which is negative. So then cotangent is negative. So the only ones that are positive here in quadrant 2 are sine and cosecant. So sine of x and cosecant of x. Okay, if I draw a random one here, my x values are negative. My y values are also negative. So sine is negative, which means cosecant's negative, so that's not helpful. Cosine is negative, which means secant is negative. Tangent is y over x, so negative over negative, which is positive. So tangent here is positive, which means automatically cotangent also is. So in this case, the only ones that are positive are tangent of x and cotangent of x. And then the last one, I'm going to draw a random line. My x values are positive, my y values are negative. So sine is my y values, that's not positive, so neither is cosecant. Cosine is positive, which means that secant is also positive. Tangent will be negative over positive, which is negative, so then cotangent will also be negative. So in quadrant 4, the only ones that are positive are cosine of x and secant of x. And the reason that these are important, you guys, is when we look at the next couple problems, we're just going to have to know where are my positives and where are my negatives. And the biggest thing is remembering that cosine of x is my x coordinate and sine of x is my y coordinate. So sine is x, sine is y, cosine is x. So let's look at our examples here on how we're kind of going to be using that information to our benefit. Okay, so it says let theta be an angle in standard position. Name the quadrant in which theta lies. This is how I kind of like to do it. So I look at my information here. I'm given that sine of theta is less than 0. Sine is my y's, right? So my y's are negative is what that's telling me. So the areas in which my y's are negative are down there. So it could be quadrant 3 or it could be quadrant 4. Right? So this is telling me that y is less than 0. Then cosine are my x's. So here it's telling me that x is greater than 0. So x is positive. Well, x is positive here in quadrant 1 and here in quadrant 4. So then I'm just looking for where it's double shaded, which is right here in quadrant 4. So this angle lies in quadrant 4. I don't know what the angle is, but I know that it's in quadrant 4. Okay. Next one tells me that tangent is negative. Remember, tangent is y over x. So if tangent is negative, that means that either y is positive and x is negative, or x is positive and y is negative. So x is positive and y is negative here. Sorry, x is negative, y is positive here. And then x is positive and y is negative here. So it's either 2 or 4. Then it also tells me that y is less than 0, meaning my y coordinates are negative, which we already know is quadrants 3 and 4. So again, this overlaps at quadrant 4. So this angle is in quadrant 4. Okay, last one is cotangent, which is x over y. So this is telling me that cotangent is positive. So that means that both my x and y have to be positive, which is here, or both my x and y have to be negative, which is here, right? Because if they're both negative, then when they divide, they make positive. And then this tells me that 1 over cosine is negative. So 1 over cosine, when cosine is negative, secant is negative. So I can just think, when is cosine negative? Cosine are my x values, so when are my x values negative? And that's in quadrants 2 and 3. So where does it overlap? It overlaps here in quadrant 3. So we're kind of using that information on when is it positive, when is it negative, to help us figure out what quadrant it's going to be in. Okay, so now let's look at example 2. Here I'm given what sine of theta is, and then I'm also told that tangent of theta is greater than 0, and it wants me to find the cosine of theta and the cotangent of theta. So there's lots of different ways that we can do this, but I'm going to start by saying, hey, I know that sine of theta is negative 2/3, and I know that sine is y over r, right? Opposite over hypotenuse. So what I'm going to do is I'm going to kind of sketch this out. I also know that tangent, which is y over x, is greater than 0. So if tangent is greater than 0, that means that when I'm dividing my x and y, or my y and x, it has to either be both be positive, which is here, or both be negative, which is here. So I know it's going to be in either quadrant 1 or quadrant 3. Since sine, my y is negative, right? Do you see that? How my y is negative 2? So that tells me it's going to be down here in quadrant 2. So just using information that I'm given, I'm able to figure out that it's in quadrant 2. And I'm just estimating what it looks like, okay? So then I know that this is negative 2, and I know that this is 3. From there, I have a right triangle right here. Oops, there we go. Here's my theta, and I can just use Pythagorean's theorem again. So, right, a squared plus b squared equals c squared. In this case, I'm going to say my a is negative 2. I don't know what b is. That's what I'm trying to find. And c is 3. So let's solve. 4 plus b squared equals 9. So I have b squared is equal to 5. And then I get b is equal to plus or minus the square root of 5. Don't forget your plus or minus. Okay, then I have to figure out, is it plus or is it minus? So this right here is square root of 5. And because of where it's located here in quadrant 3, it's actually negative. So this tells me that my b is equal to negative square root of 5. So there's that. Okay, now I know my x, my y, and my r, right? So I can find cosine of theta. So cosine of theta is adjacent, so negative square root of 5 over hypotenuse. So there's my cosine of theta. Again, I still don't know what theta is. I don't know what that angle is, and that's okay. And then cotangent of theta is, so tangent is opposite over adjacent, so cotangent would be adjacent over opposite. And since they're both negative, I can get rid of that negative. So I just get root 5 over 2. And there's my cosine and my cotangent. So once you know all 3 parts of that triangle, then you can go ahead and find any trig function it's asking you to find. The last question that we're going to do on this page is example 3, which is when we're looking at quadrantal angles, which are just angles that occur on the axes, right? So like if there is no positive, negative, right? Like here's 0, here's pi over 2, pi, and 3 pi over 2. How do I find the sine and cosine of those? And so all this means right here is that the terminal side is on an x-axis, or is on an axis, not the x-axis, but just an axis. Okay, so let's make like a little chart. I feel like that will be easier. So we're going to evaluate sine of theta, and we're going to evaluate cosine of theta. And we're going to do this for this different angles. So let's start with 0. Sine of 0. So remember this point right here is 1, 0. So sine is 0, cosine is 1. Okay, let's move on to pi over 2. This is the point 0, 1. So sine is 1, cosine is 0. Then we'll move on to pi, which is the point negative 1, 0. So sine is 0, cosine is negative 1. And then 3 pi over 2 is the last one, which is the point 0, negative 1. So sine is negative 1, cosine is 0. And that's it. The last thing that we're going to do in this lesson is we're going to look at some, oh, sorry, not the last thing, but we're going to look at some reference angles now. So just as a review of reference angles, I know that we talked about it, I believe it's in 4.1, but just to review it, a reference angle is where is just the acute angle between the terminal side and the x-axis. You always go to the x-axis. So in this case, that's theta. Okay, if I have another example like here, right, I'm always going to the x-axis. So that's the reference angle. If I have something that's going in the negative direction, that's still your reference angle, is going to the x-axis. So it's always the angle that goes to the x-axis. It should never be greater than 90 since it's always an acute angle. Okay, so we're just going to do some quick practice here on how do you find the reference angle. So let's scroll down. So it says find the reference angle theta prime for each angle. So I'm going to draw this. 300, I know, is right around here, right? So here's the angle, 300 degrees. However, the reference angle is always the distance then to the x-axis. So this is theta prime. Okay, so in this case, theta prime, right, is 60 degrees. I know that if I'm at 300, I need to go another 60 to get to 360. So we're either using 360 or 180 or even 0, okay? For B, this is in radians, right? It doesn't have a degree symbol. It's in radians. Remember our radians, right? This is pi, so that's 3.14, and this was 1.5 something. So it's somewhere between this, right? So I'm just going to draw it however, right? So this right here is 2.3. And then this guy right here is theta prime. Well, we should never be using 3.14, right? We should always use the exact, which is pi. So I know that if I have pi, I'm going to kind of give myself some more room here. If I have pi and I subtract to the angle 2.3, I should get theta prime. And I'm going to do that with the actual pi button on my calculator. Okay, and I get that theta prime is about 0.842. So it's just the angle from your terminal side, wherever your angle is, to the x-axis. Okay, last one here, negative 135 degrees. So again, I know that this is negative 90, and I know that this is negative 180. So it's going to be between here. So it's somewhere in here. And then again, that terminal side to the x-axis. So it's going to be right there, going to negative 180. So if this right here is 135, negative 135, and I'm going to 180, I can just find the difference, right? How much more do I have to go to get to 180? So I should get that theta prime, is about 45 degrees. I don't need to put negative. I just know that I need to go another 45 degrees to get to that, to get to the x-axis, essentially to get to the 180. And that's kind of it for reference angles. But again, it's going to be really helpful for us later on to be able to find that reference angle. Hopefully it's not too complicated there, but if you have any questions on it, just make sure that you reach out and let me know. Okay, so now we're going to use these reference angles to evaluate our trig functions. So the first thing is that we determine the value for the associated reference angle. So what they give you, I'm going to draw the angle just because I know that it helps me personally to see it visually. And then from there, we can find what it is that it's asking us to find. So on this particular problem, we are not allowed to use a calculator. There will be a lot of problems in this unit that are non-calculator problems, okay? So I'm going to go ahead and draw this. I know where this should not be a degree, sorry. I know where 4 pi over 3 is, right? Here's 1 pi over 3. Here's 2 pi over 3. 3 pi over 3 is 1, right? And then 4 pi over 3 is here. So here's 4 pi over 3. Okay, now what helps me here, and still to this day it helps me personally, is if I were to draw the triangle, and I usually do this in my head, excuse me, this side length, this x length, is a lot shorter than my y length. So that tells me that the x is going to be 1/2 and the y is going to be root 3 over 2 because root 3 over 2 is bigger than 1/2. So that's how I figure out the values there, okay? So that's how I figure out, and then I figure out whether it's negative or positive. So in this case, they're both negative. So my x is negative 1/2 and my y is negative root 3 over 2. And so I just kind of use that method in my head to be like, okay, which length is longer? Okay, so I found the coordinate for 4 pi over 3, and it wants the cosine, which is just the x-coordinate. So cosine of 4 pi over 3 is just negative 1/2, because it's the x-coordinate of that. And that's it. Boom, done. Okay. The next one, tangent of negative 210. Well, remember this is negative 180, right? So negative 210 is going to be here. And I'm interested in the reference angle, right? I know that this is 210, which tells me that this is 30 degrees. Well, since that's 30 degrees, I now know that this is 5 pi over 6. And that's just because we're getting used to the unit circle and we're learning things about the unit circle, okay? So if I were to draw that triangle, here my x value would be a lot bigger. So my x value is negative root 3 over 2, and my y value is positive 1/2. And I've been able to find that because of my reference angle. And it wants tangent, right? So it wants y over x. So 1/2 over negative root 3 over 2. And we don't like to write it like that. We'll write it next to each other, negative root 3 over 2. How do we divide fractions? Copy dot flip. So 1/2 times negative 2 over root 3. The 2's can cancel, and I get negative 1 over square root of 3. I can't have root 3 on the bottom, so I need to multiply both the top and the bottom by root 3. And I get negative root 3 over 3. So the tangent of negative 210 degrees is equal to negative root 3 over 3. So a little bit of extra work there, but again, it's just finding where that angle is. Okay, last one. Cosecant of 11 pi over 4. I'll worry about the cosecant later. I just need to find where is 11 pi over 4. Well, I know that 8 pi over 4 is 2 pi, and then I have another 3 pi over 4 to get to 11 pi over 4. So this is 2 pi. I don't really care about 2 pi because it's just all the way around, so whatever, okay? And then 3 pi over 4 is 1 pi over 4, 2 pi over 4, 3 pi over 4. So something like that right there. And hopefully we know my x-coordinate is going to be negative root 2 over 2, and my y-coordinate is going to be root 2 over 2 positive. So that's great. Now I want cosecant. So cosecant, if we remember, is 1 over sine. So I'm going to take my sine, which is positive root 2 over 2, and I'm going to take the reciprocal of it. So 2 over root 2. Can't have root 2, so I'm going to have to multiply by root 2 over root 2. And I get 2 root 2 over 2. The 2's can cancel. So I get cosecant of 11 pi over 4 is just square root of 2. So just knowing how to find those angles and find where those angles are located is going to be very, very helpful. Alrighty. Again, if you have questions on that, make sure that you reach out. We're going to keep going to example 6. Okay. And again, we're going to use the information that we're given to try to solve the problem. So it says, let theta be an angle in quadrant 2. Okay, so I know it's up here. That's exciting. Such that sine of theta is equal to 1/3. Find cosine of theta by using trigonometric identities. So one of the trig identities that we talked about last semester was sine squared of, I don't want to use x, sorry, sine squared of theta plus cosine squared of theta equals 1. That was the trig identity from last semester. So we can use this one. Sine is 1/3, so this is 1/3 squared plus cosine squared equals 1. Well, 1/3 squared is 1/9, right? 1 squared is 1, 3 squared is 9, plus cosine squared of theta equals 1. I'm going to subtract 1/9 to the other side. And we should be feeling good about fractions. 1 is 9/9, minus 1/9 is 8/9. And then when I take the square root, cosine of theta equals plus or minus, don't forget your plus or minus. You take the square root of the top and the square root of the bottom, which is 3. And I don't like square root of 8. I'm going to simplify square root of 8. So square root of 8 is 4 and 2, and then 4 is 2 and 2. So there's a pair. So I get 2√2. So 2√2/3. And then the question is it positive or negative? Well, if it's in quadrant 2 and it's cosine, remember cosine are my x values. My x values are negative. So it's going to be negative. Okay, so there's cosine of theta is -√2/2. That is one way to do it. Another way to do it is you can draw out the triangle. I know it's in quadrant 2, right? So here's my triangle. There's theta. I know that sine is 1/3. So sine of theta equals 1/3. So this is opposite and this is hypotenuse. So opposite is 1, hypotenuse is 3. And then I can use Pythagorean's theorem, right? Because it's a right triangle, so I can do 1 squared plus b squared equals 3 squared. So 1 plus b squared equals 9. Subtract 1, I get b squared equals 9. So b is equal to b squared is 8. Plus or minus the square root of 8, which again simplifies into plus or minus 2√2. And so then you have to ask yourself, is it positive or negative? And again, it's negative because it's in quadrant 2. So then you can say, okay, so cosine of theta is adjacent, which is -2√2, over hypotenuse, which is 3. So that is another way to do it. So 2 different ways. We have a U try here. Make sure you read the problem very carefully. It might be easier than you think. But try it. It says, let theta be an angle in quadrant 1 such that cosine of theta is 5/8. Find secant of theta by using trig identities. So go ahead and try it, and then when you're ready, check your answers, hit play. Okay, so let's look at this. I know that, so 1, it's in angle 1, or it's in quadrant 1, excuse me. And I know that cosine is 5/8. So that means that this is 5 and this is 8. Okay, wants me to find secant. Well, I don't know about you, but I know that cosine of theta is 1 over secant of theta. Or vice versa, secant of theta is equal to 1 over cosine of theta. They're reciprocals of each other. So if cosine of theta is 5/8, then secant of theta is the reciprocal, which is just 8/5. And I don't have to do any extra work there. But even if you did, you should have still gotten 8/5. Okay, last example here in this lesson is some calculator work. So really quickly, I want you to pause the video, use your calculator to evaluate these functions, and then hit play and check your work. All right, so check your work here. The biggest thing is for A, you have to make sure that you are in degrees on your calculator. We've been doing a lot of stuff with radians. If you are not in degrees on your calculator, you would not have gotten the right answer on that. Then you have to switch back over to radians for B, and then stay in radians again for C. And then just make sure that you're not using the inverse function for A and C, but you're taking 1 over the trig function to get those. If that's still not working out on your calculator for me, for you, excuse me, just reach out and let me know. And I'm sure it's just something's weird is going on and we can fix it pretty easily. All right, guys, that's it for 4-4. Hopefully that wasn't too bad. Have a wonderful day. I will see you soon.